All right, hello, college algebra students. I want to tell you about logarithms. Technically, that sort of starts in section 5.3, logarithms. But to start to discuss logarithms, maybe, and I already previewed the idea, they're the inverse of an exponential function. So let's talk about these exponential functions. We've been talking about them. Here's one, y equals 10 to the x. If I plot a few points, plug in a 0, we've done some of this. 10 to the 0 is a 1, anything to the 0 is 1. Plug in a 1, 10 to the first is 10. Plug in a 2, 10 squared is 100, and so on. Let me try a negative 1. If I plug in a negative 1, that's 10 to the negative 1, that's 1/10. You drop it into the denominator, that's 1/10. It helps to remember some rules of exponents. Hey, if I plot these points, 0, 1 is that y-intercept there. When I plugged in a 1, I got 10. That's pretty steep. This is 2 is 100. Negative 1 is 1/10. So this is a very steep exponential function. I mean, they're all pretty steep, but when the base is bigger, it's pretty steep. So that base of 10 makes it a very steep exponential function. Now, if you remember from the beginning of this chapter, if I want to find the inverse of a function, one of the book's method was to switch x and y. So if I take this equation and switch x and y, I'm going to go over here. If I switch x and y, then x equals 10 to the y. So I've just switched x and y. By the way, if I made a little chart for that, all these x's and y's would be switched. This is the inverse function. But it's the inverse function, but the next step was to solve for y. And so to solve for y, mathematicians have invented this notation. I mean, y is the exponent, and there's no real way to unexponentiate that until we invent the concept of logarithms. So we rewrite this as this. Y equals the log base 10 of x. So that's a little subscript 10 that tells me the base of the logarithm. There's all kinds of logarithms, just like there's all kinds of exponential functions with different bases. There's all kinds of logarithms with different bases. And this particular one is the inverse of this one. So this logarithm function is the inverse of this guy. This logarithm function is the inverse of this exponential function. So if I made a little, so what is this? So why, what is a logarithm? So here it is, and you kind of know it because you learned how it came from this. But y, here's what the answer to a logarithm, y, the answer y is the exponent. You can tell, there it is. It's the exponent you put on the base. In this case, the base is 10. In order to get x. In order to get x. That's a long sentence, but it helps when you say that y, the answer to a logarithm is the exponent you put on the base in order to get x. There's sort of a rhythm to it. Get it? Logarithm. So let's try a few. I could plot some points for this. I could make a little chart for this guy, x and y. If I plug in a, let's see, start somewhere. If I plugged in a 10, I'm plugging in a 10 for x. I'm looking for y, which is the exponent you put on the base 10 in order to get 10. What exponent do you put on 10 in order to get a 10? I think the exponent would be 1. By the way, that's this reversed, remember? That's this ordered pair reversed. What if you plug in 100 for x? I'm plugging in 100 for x. I'm looking for the exponent that you put on the 10, the base 10, in order to get 100. I'm looking for the exponent that you put on 10 in order to get 100. It doesn't take long for you. When you say that to yourself, the answer is 2. What about 1,000? If I plug in 1,000 for x, I'm looking for the exponent you put on 10, the base is 10, to get 1,000. Looking for the exponent, I think it would be 3. I think 10 times 10 times 10, 10 cubed is 1,000. What about a 1? I'm looking for an exponent that you put on 10 in order to get a 1. I think that's 0. By the way, it's this one reversed. What about a 1/10? I'm looking for an exponent that you put on 10 in order to get a 1/10. The exponent that helps you get a 1/10 is a negative exponent, a -1. So like I said, so I'm just trying to help you talk your way through what is a logarithm. And I'm plugging in numbers and I'm doing this logarithm function. I'm evaluating this logarithm function for some famous numbers. You know, when you plot those points, you get a graph. I'm very interested in these exponential graphs, you know, but I'm going to show you this graph, but I really don't ask you a lot of questions about logarithm graphs, but I want to show it to you. If I plot these points, it's 1, 0. When x is 10, I got a 1. When x way out here, when x is 100, you get a 2. When x is 1,000, you get a 3. So this is a slowly rising function. Remember, the exponential function rises very steeply. His inverse, the logarithm function, rises very slowly. But right here, it takes a steep dive, and it dives toward this asymptote. This acts like a vertical asymptote. Oh yeah, remember, there was a horizontal asymptote here. And maybe you can remember these are inverse functions. They're mirror images around this mirror, this diagonal mirror. So here's a picture of the graph of the log function. You can tell that its domain, you can only plug in x is greater than 0. It never touches this 0. You're not allowed to, if you plug in a 0, it's undefined. Or any negative numbers. It just starts here and it's x is greater than 0 is the domain. All right, let's talk about a couple more things here. So you know, I can just start, now that you know what a logarithm is, if I just throw a logarithm at you, what is the log base 2 of 8? That's kind of a famous one, but you should talk to yourself. You should say, all right, I'm looking for the exponent that you put on 2 in order to get 8. I'm looking for the exponent you put on 2 in order, the answer's 3. What if I'm looking for the log base 2 of 32? You know, let's just say I don't know the answer. The answer is some answer y. Sometimes what helps is to rewrite the logarithm. I just talked you through the sentence and we came up with the answer 3. and the reason is because the base 2 raised to the exponent 3 is the answer 8. And that's it. So sometimes, let's say we don't know that answer, and so it helps to rewrite the logarithm. If you can rewrite the logarithm in exponential form, and you might have some homework that does that, it helps you think about it, it helps you solve it. So if I rewrote the logarithm, now let's start with the base. The base is 2. I'm raising it to the exponent, which is the answer to the logarithm is the exponent y, and it equals 32. So just rewriting it, 2 to the y equals 32, which is kind of what this says. Remember, we got this from rewriting this. Anyway, then you're staring at this, and maybe you pick up a calculator, maybe you figure it out. 2 times 2 times 2 times 2, 2 to the 5th equals, so y is 5. The answer to the logarithm is 5. It's the exponent you put on 2 in order to get 32. Here, let's try another one. The log base 6 of 1/6. You know, maybe rewriting it helps. I kind of know the answer. I'm looking for the exponent. You put on 6. I think it's a -1. The answer can be negative. You're not allowed to input any negative numbers. The domain, you're not allowed to input a negative number, but the answer could be negative exponents. Okay. That's good stuff. I'm going to keep talking here a minute. So I'm trying to get you to do some logarithms without a calculator. But logarithms are famously done with a calculator. You know, and so there's these two famous logarithms usually on your calculator. There's log base 10 of x. That's a very famous logarithm. When it's base 10, it's used a lot in chemistry and science. And anyway, it's so common that they often they say we don't have to write the little base 10. We don't have to write we don't write the base 10. We know it's base 10, and that's a button on your calculator. And by the way, we'll use the phrase common. I've heard this called a common logarithm. Base 10, very famous. You don't have to write the base. It's called a common logarithm. There's this one, log base e of x. I introduced this earlier in this chapter, but I didn't call it log base e of x. When it is log base e of x, we always write this, ln of x. We call it the natural logarithm. And we don't have to write the base. When you see somebody write ln, we know it's base e. So ln is a base e logarithm. Log without a subscript is a base 10 logarithm. But any other logarithm, if it's log base 2 or log base 6, we have to write the little subscript to tell you what the base is. So these are famous buttons on your calculator. You could try this. What's the log of 5,432? That's not one I do in my head. That's not one I figure out. Although you could play this game. What's the base on this? What is the base? Oh, it's base 10. So, what is 10 squared? 100? Yeah, that's not. What is 10 cubed? 1,000? Okay, it's bigger than that. What's 10 to the 4th? 10,000. All right, I'm trying to find the exponent that gets me 5,432. If it's exponents of 3, I get 1,000. If the exponent's of 4, I get 10,000. So it must be between 3 and 4. 5,004. So, but I punch it in my calculator. So you should try that. I'll try it real quick here. Let me see. LOG 5432. I'm predicting it's between 3 and 4, and the answer is 3.7. Right. The answer is 3.735. We tend to go for 3 decimals, it seems like. So there you go. That's the exponent. 10 to the 3.735 will get you this. All right, I'm going to hit pause. I got more to say about logarithms. I need to talk about the properties of logarithms next. We'll do another video in a second.